Welcome to The Explainer. Today, we are going on an absolutely incredible journey together. We're going to explore the absolute limits of our current cosmic understanding, taking a really structured look at the frontiers of the unknown. We're going to travel from the mind-bending edge of the universe itself and then zoom all the way down into our own solar system to explore the microscopic origins of life. Okay, let's dive right into this. Here's our roadmap for today. We'll kick things off at the macro scale with the edge of the universe, move on to the Planet 9 anomaly, and track our Voyager probes out in interstellar space. Then, we'll pivot to the micro scale, looking at Earth's recipe for life, and finally apply that exact recipe to the alien oceans of Europa. Frontier 1, the edge of the universe. Now, to start us off, I want you to imagine turning on an old vintage TV set and flipping to a channel with no signal. You know that fuzzy black and white static, right? Well, what you're actually looking at is partly the cosmic microwave background. It's the residual echo, literally the white noise, of our universe's birth. Seeing that ancient echo poses a massive question, doesn't it? One that really challenges a common assumption we all make. Is the universe truly infinite, or does it actually have an edge? See, if it were truly infinite in both time and space, our night sky would be blindingly bright, just densely packed with an infinite number of stars. But the sky is dark, and that darkness tells us the universe has a finite timeline, which brings us to the physics of how everything we know actually emerged. It all started with a singularity, a single point of incredibly densely packed matter and energy. To really picture the Big Bang, try this. Take a piece of paper, draw a tiny dot on it, and then violently crush that paper down in your fist until it's the exact size of the dot. That immense pressure you feel in your hand, that's like the early universe. The Big Bang wasn't just some random explosion. It was like that crushed paper violently attempting to unravel and expand back into its normal form. And this brilliantly illustrates the two major theories of what is happening at the literal edge of everything. First, we have inflation theory, which suggests our universe is expanding exponentially. That means there isn't a concrete geographic boundary or wall at all. But then we have a fascinating alternative proposed by researchers like Paul Steinhardt and Neil Turok, the Cyclic Universe theory. Based on string theory, this model suggests matter exists in up to 50 hidden dimensions, and our universe might just be a byproduct of two three-dimensional worlds colliding. In this model, the edge isn't a wall, it's just the boundary where our universe interacts with another one, sparking endless cycles of expansion and compression. Wild, right? Frontier 2, the Planet 9 anomaly. You know, we really don't need to look out to the multidimensional edge of the universe for profound mysteries. We just need to look at the edge of our own solar system out in the dark, icy reaches right past Neptune. Deep out in the Kuiper Belt, astrophysicists Konstantin Batygin and Michael Brown noticed some incredibly strange gravitational behavior. They found 6 distant dwarf planets that are inexplicably orbiting in a perfectly synchronized direction. And even weirder, their orbits are tilted at a bizarre 30-degree downward angle. Brown compared it to looking at a clock where 6 hands are moving at entirely different speeds, yet somehow, whenever you look up, they're all pointing to the exact same spot on the clock face. Which brings us to this incredible data point, 0.7%. That is the mathematical probability of these 6 Kuiper Belt objects aligning this way, totally naturally, without some unseen massive gravitational force pulling on them. It's practically zero. Something massive is out there, hiding in the dark. Now, what's really interesting here is the sheer contrast in what this hidden object could actually be. The leading theory is a massive gas giant, roughly 5 to 20 times the mass of Earth. But because we haven't seen it yet, physicists have proposed much wilder theories. It could actually be a primordial black hole, a tiny, ancient black hole literally the size of a grapefruit, just sitting there emitting faint Hawking radiation. There's even a radical hypothesis that it's a static planet made entirely of dark matter, wrapped up in an invisible shell of helium and hydrogen. Frontier 3, Voyagers in interstellar space. So, while astrophysicists are searching the dark for unseen planets, human-made probes are already physically pushing past those solar boundaries into the true interstellar unknown. Let's just take a quick look at the timeline of the Voyager missions. These twin probes were launched way back in 1977, taking advantage of a rare planetary alignment that only happens once every 176 years. Over decades, running on radioactive power and ancient, indefinitely reprogrammable computers, they made history. Voyager 1 crossed into interstellar space in 2012, followed by Voyager 2 in 2018. They're still transmitting data today and are projected to celebrate their 50th birthdays alive in deep space in 2027. But leaving the solar system wasn't exactly a peaceful exit. They had to cross something called the heliopause. That's the invisible, turbulent boundary where the solar wind is finally stopped by the interstellar medium. The absolute best way to visualize this violent crash is to imagine running tap water hitting the bottom of a sink. The clear water pushing outward is the solar wind, and that turbulent, chaotic ridge where the falling water forcefully meets the stagnant water pooling around it, that is the heliopause. Our probes had to violently crash right through that cosmic ridge. And once they got to the other side, things got weird. You might have heard those internet rumors about Voyager 1 picking up a mysterious Morse code message from aliens. Well, let me just clarify that those are definitely myths. However, the truth is just as fascinating. Voyager 1 is picking up a low-frequency humming sound. It's likely a foam effect, an amalgamation of various vibrations of interstellar space. As plasma and interstellar matter crash into the heliopause at hypersonic speeds, they churn into a sort of cosmic seafoam, creating a constant, eerie vibration that the probe is recording right now. Frontier 4, Earth's Recipe for Life. Okay, I want us to completely shift our narrative scale for a second. We're zooming in from the macro borders of deep space down to the micro borders of biology, looking at our own planet's violently beautiful beginnings. Today, our Earth is perfectly balanced to sustain us, with oceans covering about 70% of the surface. We know that life transitioned from that water to land. But to understand how life started, we have to remember that ancient Earth was once an incredibly inhospitable, 1,200-degree stew of molten lava and toxic gases. Those massive, life-giving oceans only accumulated over millions of years through relentless, punishing meteorite bombardments that delivered water droplet by droplet to the cooling crust. So the crucial point here is this structural recipe, kind of a cosmic checklist for life. First, you need liquid water acting as a solvent. Second, you need a way for inorganic elements to turn organic. According to the famous Oparin-Haldane theory, early Earth's endless ocean storms produced massive lightning strikes. These electrical charges hit the atmospheric gases, transforming them into organic matter that literally rained down, creating a single-celled organic broth. And finally, you need an energy source, like solar energy, to eventually drive photosynthesis. Frontier 5, Alien Oceans on Europa. Now, that checklist perfectly explains our existence, but it forces us to ask a thrilling question. Is there anywhere else in our solar system that shares these exact same ingredients? The answer is yes, and it's right in our cosmic backyard. Let's see how this builds perfectly onto Jupiter's icy moon Europa. Just look at Europa's life checklist. First, liquid water. Europa hides a subglacial saltwater ocean that is estimated to be twice the size of all Earth's oceans combined. Second, chemical elements. We've detected oxygen and heavy salts in its shifting ice crust. Third, energy. Now, while it's too far from the sun, it gets massive energy from Jupiter's intense radiation and likely from deep subglacial hydrothermal vents on its ocean floor. This exact match is exactly why scientists are so desperate to explore it with the upcoming JUICE and Europa Clipper missions. So, just how active is this hidden ocean? Well, look at this massive number, 125 miles. Scientists have recorded geysers bursting from Europa's ice crust that shoot warm ice and water 125 miles high into space. The crust of the moon acts like shifting puzzle pieces, constantly cracking from the friction of Jupiter's immense gravity, revealing the churning ocean right beneath it. And the physics inside that ocean? They might be wonderfully, completely alien. Because of the density of the salt water compared to the ice, scientists believe Europa experiences upside-down snow. Flakes of ice literally form deep in the water and fall upwards from the ocean floor, attaching to the bottom of the ice crust, creating inverted, upside-down mountains. It's an environment so incredibly active, it actually alters Jupiter's massive magnetic field. Which leaves us with this final, thrilling thought to conclude our explainer today. If the turbulent, violently hot edges of our early universe forged the exact planetary ingredients needed for life to miraculously arise here on Earth, what in the world is waiting to be discovered right now, swimming in the dark, upside-down snowstorms of Europa? Thank you so much for exploring the unknown with me today. Keep seeking answers, and I'll see you in the next explainer.